Hi, my name is Stephen Proud, and today I'm going to show you some concepts using a CMMP-AS-M0 controller from Festo. It's a motor controller, and I'm going to show you some record mode configuration and commissioning techniques.
So the first thing that we're going to need is we're going to need software. So the Festo website is where you go to get this. Type in the Festo website here. You go to support/downloads at the top here. Simply type in either your motor controller part number or type code. In this case, we're using this particular one here, the M0, the smallest one. Click on the software tab. Underneath the software tab, we have all the software. Okay, we're looking for the Festo Configuration Tool plugin. In this case, we're the latest software, as we see on the website here, is 250479. You will click on this and download the exe file. If you look in the bottom left-hand corner of the screen, it says 250479.prerequisite.exe. You will download that, double-click it, and install the software. I'm not going to show that today. I hope you know how to install software. The next thing is to start up the software. Okay, I've got quite a few projects here. So when you first start up the software, you can either come up and click on New under Project. One thing to think about under the options, turn off this here, otherwise it opens up the last project first every time before you need to go to another project. Either click New Project here or New Project in the menu here. So New Project. Okay. All right. So after you've installed the software, likely if it's the only software you've installed on your system, you will not have all of these to choose from. You will only have this particular one here. So you click on the CMMP, you make sure you have the right version. Typically the latest one is what you want. Give the access a name. And it's going to start by creating a shell of a project. At this point in time, you need to configure it with the hardware. So whatever hardware you've purchased from Festo, you need to add that. So first page, create new drive configuration, select your motor controller, the M0, select your model number. In this case, I have this particular version. We're not using internal circuit coupling. Festo motor. EMME I'm using. It's an 80S. I do not have a gearbox. So standard motor out of the box. Next, select linear motor. And in this case, I have a EGC tooth belt, 70, 210 millimeter stroke. So this is what we've configured here. Hit the finish. Okay. Now from this point on, you can click in different locations here. But when you're a newbie or a beginner, you really want to use these next and previous buttons at the top right here. So I'm just going to use the next button. This is device information. It will look different after you've gone online and saved the project once. It'll store this information offline for you. This is important here because this is where you select the communication protocol. In our case, we're not using field bus in any way or an analog input. We're using digital I/O, and we're going to select record sequence. And we'll select a couple other things that are related to positioning. Hit the next button. Extremely important here to put the load in If you don't know the load, find out what the load is, because the way the Festo software calculates the gains is based on the load. And if you don't give it the right load, then your system will operate very poorly. It'll be overtuned or undertuned. See, it tells you here you need to recalculate the closed loop settings afterwards, but we'll get to that. So hit the next button. At this point, it's important to open up the Festo catalog for the axis that you've purchased and put in the smallest target you can reach. The following area you can play with later. A couple of other things are something else to be discussed later. Again, for newbies or beginners, a very important part of the software feature is this dynamic help. So on the right hand side here, this help will always be here, and when you click in an area, it should give you the detailed information for that. So if you click on the velocity reach, it tells you that the velocity reach is over here. It tells you a little bit about that. So it's best that you leave that turned on until you get used to the software. If you're looking for full help, you go up to the help, content of installed plugins, and you physically select what your plugin or your controller, your motor controller is. So in this case, you would select CMMP-AS, and give me a second here. So you've got the CMMS-A plugin, gives you system requirements, using the help system, description of special topics. So list the diagnostic messages. So if there's a fault in the system, they're all right here. So very simple things. Okay, keep going here. So the next button. This is something that you don't play with. If you do play with this, you could potentially damage the motor. This is the FCT software itself populates this, and these values might not actually be nameplate data on the motor, but they're related to. So the FCT software here does not necessarily use the nameplate data off the motor. It calculates the motor current based on this assembly that you've configured here, so that it doesn't overload the axis and doesn't overload the motor. This particular controller has a brake, and the default, I'm just going to leave the default for unlocking this. Nothing to do here. This is an extremely important part of the project. The stop decelerations, you enable editing, you can change these. These are program deceleration limits used during faults, both mechanical and hardware related or software related. So quick stop. So if you're moving along at 100 mile an hour and you drop the enable signals, the physical enable or the software enable, if you're using that, the axis will decelerate at this value here. If you encounter an over travel limit switch, it will decelerate at this value. If you encounter a software limit, it will decelerate at this value. So these values here are something that you should be looking at in comparison to your system, so that you decel at the quickest possible thing without quickest possible deceleration based on what your mechanical system can handle. I mean, if you damage your mechanical system while decelerating this, then it's kind of pointless to have that high deceleration. So you got to kind of weigh out your safety to mechanical damage problems. These here are just other general limitations that you'll see throughout the project. The limit switches up top here, you can either select normally open, normally closed. My particular one, I'm using limit switches and I've got normally closed. The reference switch is not being used at all. So hit the next button. For my purpose, I'm not going to use a limit switch. I'm going to use current position, just for the sake of this project. Next. If you want, you can, every time you want to turn on the power staging controller enabled, it will home itself. A lot of people don't use that because you kind of want to home it when you want to. Next button. So I'm going to leave this all default, so there's nothing else here to do. My axis stroke is that. My feed constant is this. And there's the gains. The gains here are calculated. I'm going to enable editing. I know my gains. I've manually tuned them before. 8.38. Hit the next button. Okay, there's a couple inputs if you want to make available that you're not using your analog inputs. You can make those available for digital inputs. Same thing with your digital outputs. However, normally you would need your digital outputs because it's important to close the loop on how you control the system. So normally you wouldn't use these. It's possible you'll use these. This is all default, so you have these particular digital inputs here to select the binary record. You have a start input. Staying with the defaults are important. It just makes more sense. Nothing else here needs to be set. You can set the digital inputs for jogging. So let's do this. We'll use 12 and 13, and we'll do 12 and 13 for the jogs. Hit the next. Keep going. Don't need that. This gives you an overview of what you've set all your inputs for. If there's a yellow, that means you've assigned 2 inputs, but if you're not using it, it's kind of not something that needs to be considered. These here over here give you a view of what they mean. The next. So MC stands for motion complete. I'm going to use MC, and over here I'm going to acknowledge for start positioning. Common interactive. Okay, this is what I always use, and it's important to use this because the motion complete tells you that the motion's finished. The acknowledge tells you that what you're telling it to do has been acknowledged, and the common error means that any error is active. Hit the next button. This is jog mode, and now we get to the point where we can populate a table. So put a number in here, and we get a. I'm just gonna close this for a minute so you see everything here. You got an Excel, decel, velocity. You can copy. Okay, so that's how you do some things. Another way of entering data on the line here is double click that, and this helps you a little bit further because to the right of each field it gives you the min and max. Again, good for newbies. Basically, and decel start. I'm not going to get into what record sequence is. You can read that in the help files. It's going to do some standard base moves. Absolute positioning. Hit OK. I'm just going to change the target again. Save the project. Okay, this here allows you to configure how you like your messages. Again, the quick stop here. Earlier in the project, I showed you that you can program your deceleration times. That's what this refers to. If you read this over here, it's important to understand what those mean. And then the trace area, I'm not going to discuss that. It's kind of a whole topic by itself. You can scope different values while the axis is moving. And that's it. So at this point in time, we're ready to go online. So in order to get online, we need to set up an interface or select a interface. So go into FCT interface. I have an Ethernet cable plugged in, but I'm not going to use it. I'm going to use my USB cable I have plugged in. So you select OK, and now you select this here, and it should pop up a window and allow you to select what the axis is. When you click on Identify, it makes the LED on the display scroll through the word hello. So you do this, and there's HELLO on the unit, so you know you're connected to the proper one. You hit OK, and now that's going to take you online. I'm going to do a download, overwrite. So what this is doing is taking the PC project, puts it on the Valiton memory. At this point in time, if you were to cycle power, everything you've just done is lost. If you cycle power on the motor controller, the next thing you need to do to avoid that from happening is to execute the store. Okay, I just went through that message window. What that's doing is asking you about the device control down here. All right, so if I turn this off and I want to do a download, do you want to continue to download? Yes. Well, it says, hey, I need control in order for me to do something. So do you want me to set FCT device control? So look in the bottom left down here, hit the yes. So it checked the box immediately and then just downloading. Same thing in the store. When you do the store, it's doing the exact same thing. It's going to ask you, if this is not checked, it's going to ask you if he can, or if the software can turn it on. All right, so at this point in time, let's look at our hardware. With the controller right now, on the top, you've got a X1 25-pin connector, and you've got a power connector on the X9 at the very back top. You need to have that hooked up to the 120 or the 240. You need to also have that X9 connector hooked up to 24 volts. The X1 cable needs to be hooked up to your I/O. The 24 volt signal is going in and out. And the bottom connectors at the front and back need to be hooked up to your motor and your encoder. Without that, you can't do anything. As well, the front of the controller has a X40 connector that is for safe torque off signals. For example, hooking up an e-stop, those need to be wired. Otherwise, you cannot enable the controller. So this right down here, the digital I/O shows you the X1 cable status. This down here, safety functions, shows you the STO circuit. As we see here, this is both channels are active and therefore okay for power stage enable. But until we and digital input 4 and 5 here. 4 is your power stage, 5 is your controller enable. When you're trying to commission or do anything, you need those on as a minimum. And because we're using the software, if I turn the software off, turn the enable DIN 5 off, turn it back on, you get the power stage enable. If I turn this off, if I turn the FCT on, you'll see that the power stage is gone, and you need to now, through software, turn on the enable, get that power. All right, so safety functions are good. Homing, manual move. You'll see here that you cannot click on single step. Single step is doing relative moves using these values right here. You can't do that. Why can't you do that? Because the system doesn't know where it is right now. I mean, this number here means nothing. So you need to home the axis. So we're going to home the axis. Now that the axis has been homed, now we have access to do something. So I just clicked it once, click it again, it does 10 millimeter moves because that's what we're spelling out to it here. These are all relative moves. If I go backwards, forward. If I want to jog it, press and hold the button. Press and hold the button. So that's how you manually move things and jog. And then we get to our record tables. Okay, see how the yellow or the gray. So if I turn off the enable, the yellow is gone. And when there's no yellow there, that means you don't have the ability to execute that. Okay, so if you want to execute this move, you simply click on this button and it executes that move. Move to the next record. See here, it executed that move. If you look at it from a different perspective, with a little more detail, there's a target and actual value. A couple other things here. You can change what you want to be active here. You can basically simply click there, and you can see there everything's good. Okay, the last part of this is to show you operation from an external source and how you call the records. So you can be online to this controller here without being active in FCT. So at this point, the control sovereignty will have to switch over to the PLC or whatever you're controlling it with. In order, after you've had the FCT on, in order to get the control sovereignty to the other device, you have to cycle the DIN5. So if I turn the DIN5 off, turn it back on, now the other device has got control. The power stage is active. Away we go. So I'm going to just do a jog here. As we showed before, the jogging has been set up already as DIN 12 and 13. So if I turn on DIN 12 and 13, I'm jogging the axis right here, see? Let the input go off, jog it in the reverse. That's how you jog. Now, you'll see these first digital inputs here, these 1, 2, 3, 4 here, that's 0 through right here. And those select the record table, okay? So if I wanted to execute record number 2, this is a binary select. So if I wanted to execute record number 3, I would have to turn on bits 0 and 1, which in binary represents, decimal 3. If I want to do just 2, then it's the second bit, and bit 0 is just decimal equal 1. So I'm going to show you that a way of doing homing. So if you want to do a homing, all the binary select needs to be off and the start signal. So watch this right here and watch the homing valid. It should go off temporarily and come back on. It might be too quick to see. There. So I've just homed it by using this bit 8 here, digital input 8. If you look at the I/O configuration here, the start is DIN 8. Again, the binary select over here. So that's how you execute a home. You have a binary select of 0 to the start bit. You'll notice that 0, 1. So this one right here, this yellow second one over here is the MC. This third one is the acknowledge, and common error active is a failsafe, so it's off when there's no error, on when there is. So if I turn on the digital input 8, the acknowledge is the inverse of that. That's important to understand when you're sequencing. Turn it off, it goes back on. So now we want to execute a record. So again, the binary select bits right here, select the binary and then execute this. So if I want to execute record number 2, I'll turn this bit on here, and the next bit will be a digital input 8, and it's going to execute the move, and when it's done, you get the motion complete. Maybe I should add a slow move. So I'm going to add a very, very slow move so that you can see the things. Let's go, I don't know, 50. Download, yes, yes. So turn this back off, gain the access back through DIN 5. So to execute record number 4, it's the next bit. And I'm going to turn the start bit on. It's going to start moving. I'm going to turn the start bit off. Now the acknowledge change state again, and now we're waiting for the motion complete. Motion complete comes on when the move is finished. I'll do that one more time for you here. I'll just make it go back to 0. You also see here that the record number 4 was the last one executed. So I've told it to go back to record 1, and we're at 0 here. Go back to 4. So sequence of operation. Turn on DIN 8, which is right here where my cursor is. The acknowledge changes state. Then you turn off the acknowledge, change the state again, and we're waiting now for the motion complete. Motion complete happens, and that particular move that you've requested is done. And that's the gist of normal record I/O control mode in the FCT software with an M0 or CMMP-AS-M0 motor controller.